commandment. Okay, so now I'm going back here. Okay, so I'm going to run a plan 1 again. So what will happen now? Since I'm not in the origin, now I'm going to the two-way points. So what will happen? So now the behavior received is navigating to, unless just now is P5. So if I go to the waypoints that I have predefined, the first waypoint is 8 and 0. So let's see.
So for SCMMC, the simulation also using this old Holland.
Actually, we didn't build a complex simulation with indoor environment. This one is just to test whether your plan is correctly written or not.
Okay. So for us, we can also use the SCMMC circuit for this, right? I mean, we just see whether it moves according to the waypoint.
Yes.
That's the whole idea.
Yes, that's the whole idea. This one is just to make sure that you not make very small mistakes in order to result in the crash of the UAV. Okay.
How do we know it will crash? You're saying that we did something wrong with the code. How would it tell from here?
In simulation, no. But in real life, for example, if you make waypoints supposed to be 8, then you make 80 and 8. So you go all the way to 80. We may crash from something. I don't know. Yeah, that's the idea. Okay. Just now when you reach 80, right, we'll go to the 8 minus 8, which is the second waypoint. Okay, let's see what we have. Once you finish, then we'll go to the land behavior receive land. Okay, C is 0.0. It means it's landing on the ground already. Okay, so that's all for the software training.
So, outdoor and indoor the planning is the same, using the same command. Is there any difference?
Actually, the command we are providing like P5, H5, and then into.
So when we are doing outdoor and we do indoor, this one cannot do outdoor because it's no VPN.
Yes.
So you will cater everything at the signal, and then we just provide X, Y, Z
coordinate and navigate there.
It's an offset from the initial start.
Yes.
Then how come when you key, maybe you key 10, it goes up instead of over, because Z is positive now.
That's why. Okay. That's because I purposely reversed that to make it easier for people to understand.
Okay, so it's an X, Y, and Q.
Yes.
Okay.
You treat it as X, Y, and Z going on.
Okay. Then my question is, how fast do you sample your data? So for example, your ultrasonic, every
Ultrasonic This one, the distance sensor is quite tough. And it's not ultrasonic, it's a laser one.
Laser.
Yeah, this one, the sampling rate is 1000 hertz. But the sampling we are taking for the filter is 20 hertz.
20 hertz.
So
So
for
when
them
we,
also 20 hertz.
so when we go for SFNC, we fly over the door, you fly up and then hit the.
No.
Why it doesn't? Because there's a height.
Okay, that one is can be easily removed by a filter. And also there's only one, you mean across the window, right?
Let's say, okay, I fly across this table, it will go
Or
out, right?
if it's table, definitely will go out.
So how small must it be so that we will, or how do we overcome this thing shooting up and then hit the circle or hit the rectangle?
As far as I know, in SFMC, right, there are tables, but on above the tables there are nothing. There's only one window, which is only a slice of wood, so that even if the laser is there, right, we have a filter, and we can
So
fill
your
out.
setup, you take some.
It's very complex filter. You take off the position, the measurement of the distance sensor, and the barometer and accelerometer.
Also there's barometer.
Yes.
So it will do obstacle avoidance
Yes.
under which all modes or only a certain
P-flat.
only P-flat. So when we reach the chain curtain, it will just stay there and then it cannot go through. If let's say there's a curtain.
We are providing a basic and fundamental obstacle avoidance algorithms. So for the specific strategy, then you have to decide by yourself. Yeah. The only thing I can tell you is that if you have a curtain line, you scan it, you will not go.
So apart from P-flat, is there another mode which will disable the?
Navigating tool. That's why we provide three.
So can we switch halfway?
Yes, can.
How? It must be a human intervention.
No. In the code. Then you say you can specify, say for example, you reach a certain condition, and then you can, the next waypoint is you will not repeat like maybe using navigation tool and total station one.
Then when we say we want to fly to a certain offset, what condition would you consider you have reached that condition? What is the offset?
Okay, that one we keep the distance to 1 meter. If you reach to a distance of 1 meter, and then you consider to reach it. Okay, the condition that we say we have reached the waypoint is done by the navigator. But for you, say you want to drop a payload at a specific point, you can take the measurement of the UAV of current status, say X and Y, and then compare with the predefined, say a point. And then you only drop when this gets close enough. And this is determined by you. And then you can also return in the plan. Okay. Any further questions?
Yes. How do I know? You know, outdoor is easy because using GPS, you can know your exact location. But when it's indoor, how do I know exactly where I am from my start position? What reference do you use, or what reference does the system use?
Slam.
Slang. So which feature does it recognize or?
This one is through a laser scanner. So that as long as there are surrounding things that can be recognized by the laser scanner, say we are in this room, right, and there are walls, chairs, and that's, as long as it can be scanned by the laser scanner, it can be taken as a feature. So then you can do a scan and mention and get the offset, and then we integrate offset using map compared to the map. This is a typical SLAM, what a SLAM does.
Is there INS inertial navigation?
Yes, the result from the SLAM will pass into our flight controller and the INS based navigator. So not navigator, but computer will be working in order to fuse the measurement.
So everything, all this is done by you.
Yes. Any other questions? If not, we will go to the demo.
So if we are going to find the circuit, right? What if there is an obstacle in front? Will it avoid?
Sorry?
What if we are flying the circuit, right? Let's say you see there's circuits, we fly the circuits, we use navigate or use P-fly.
P-fly.
P-fly. We use P-fly, but will it avoid if you are in the corner, you will avoid, you will not move from you will avoid because there is an obstacle in the circuit.
I can only tell you that we did it before. So we
So you
avoid.
P-fly,